Hello and welcome to another tutorial. We are going to continue on discussion of the classes and objects, which are the building blocks of Java programming language and all other programming languages that build upon the concept of object-oriented programming. And we looked at several different topics, and now we're going to look at the more on classes. And these are the more topics about the properties that the Java classes have. This section covers more aspects of classes that depend on using object references or pointers and the dot operator, which we've already talked a lot about it. Whenever you want to access a method or field, something about the object and instance of a class, you use the dot operator that you learned about in the preceding sections on objects. So we've already talked a lot about most of the topics that we will see in this page, but it's good to review them and refresh them so that we gain a better understanding. Returning values from methods, we've seen that. We've talked about methods. If you recall here, we talked about method overloading, pass by reference, pass by value, and the vararg methods that accept vararg, right? This method print names is a string ... We even looked at the bytecode and we saw that what happens when we have a vararg, and we saw that behind the scenes the compiler actually converted to a regular bytecode that accepts an array. So it's not a very weird thing in the bytecode. It's expected. It's just a syntactic sugar to make life easier. Returning values from methods, the this keyword, we've already seen this, and actually we've used this a lot. Class versus instance members, access control. We've seen access modifiers. We had an in-depth understanding of the access modifiers. We discussed them mainly for basically fields. But then we said that for methods, the same rules apply, and constructors are also special methods. So the same access modifier rules that apply to methods also apply to constructors. All right, so returning a value from a method. A method returns the code that invoked it. A method returns to the code that invoked it when it completes all statements in the method, reaches a return statement. We've talked about return statement in the past when we discussed the Java language basics, and we said that the return statement has to provide something. Whatever comes after the return keyword has to provide something that is congruent or compatible with the return type that a method, the prototype or the declaration of the method promises. Every method in Java has to have some sort of access modifiers so that the JVM knows who is allowed to access it, and then it has to have some sort of return type so that JVM knows what kind of type it's going to return, right? What kind of value. Throws an exception, and we already briefly saw this, but exceptions is a topic that we have to look at in the future lectures, and it also says that we will cover that later, whichever occurs first. So either a return statement or we complete everything. Maybe if a method doesn't have a return statement because its return type is void. So you are not forced to, you are not required, or it's not mandatory to write the return statement explicitly, right? Whenever an exception is thrown, the runtime, the JVM immediately jumps out of the method regardless of what lines of code is remaining, and then basically JVM goes into a panic mode because exceptions mean some sort of error, something that wasn't unexpected, right? So JVM goes into the panic mode. Then there are mechanisms to handle those panics, and then we will look at them and how to deal with them. You declare a method's return type in its method declaration, right? That's the declaration of the method. Access modifier, return type, other type of every kind of modifier goes before the return type, right? Access modifiers, and also whether it's a static or a non-static method. Why? Because we said that in Java there is no global scope. You cannot have a freestanding functions. Functions are not first-class citizens in Java, right? That's a terminology that a lot of people use, and you will hear often that only classes are first-class citizens, right? Functions are not first-class citizens because you cannot have a freestanding function in Java, which means every function has to belong to a class, which means functions are actually methods inside the classes, right? A method cannot exist on its own. It has to be inside the class. But then Java provides a mechanism for dealing with whether a method is associated with the state of the object or not, and that's the static versus non-static method. And again, functions are not first-class citizens in Java. Functions are first-class citizens in other programming languages like C++ or Python, right? Because those languages allow for a global scope that doesn't belong to any class. But in Java, there is no global scope. Even the entry point to your application, which is the main method, has to be inside a class, right? Within the body of the method, you use the return statement to return a value. And again, if the method declares a void as the return type, you don't have to write the return statement because it doesn't return anything. Any method declared void does not return a value. It does not need to contain a return statement, but it may do so. In such a case, a return statement can be used to branch out of a control flow block and exit the method, and is simply used like this. So sometimes you have if, else, and we've seen examples of this before. Even if your method returns void, sometimes you want to, if some condition is met, you want to immediately jump out of the method and disregard the rest of the lines of code. So you can immediately say return, which means, hey, just return back to the caller, whoever called this method, or whoever invoked this method, and then ignore the rest. Let's see. I think when we talked about the operators, at some point we discussed the let's see. At some point we discussed this return keyword. Conditionals. I think it was somewhere in the conditionals. Let's see if I can find it. Switch expression, switch statement, arrays, classes, loops, return expression. So we saw that, for example, in this case, we have a static method. There is one return statement here, and there is another one here, and this one returns a string, so we have to return some type that is a string, right? And then we said that here we can have multiple return statements, and basically what happens most of the time, we want to also use return to the return statement to branch out of the or jump out of the method. So we said that if a condition is met, we can explicitly use return to to basically jump out of the method and disregard the rest of the code. And if this condition is not met, we just continue the normal flow until we eventually return something. And the JVM and the compiler also expects you to eventually return some sort of a string, because this method requires a string. And we saw that the exceptional case is when you throw exceptions, right? Or basically you either throw an exception. In that case, the JVM doesn't expect you, or the compiler doesn't expect you to return something, because it's the panic mode. Something went wrong, so we have to jump out of the method. But another case was when we saw that if you're using some other method, you have another method called inside your own method, and it throws exception, and then you can catch it, and either in the try block, catch block, or even in the finally block, you can return a separate, you can have a return statement. So each one of these blocks, try or catch or finally, they can have their own return statement. And we said that you should never use return statement in the finally, because it overrides every return that you had either in the try or catch, because regardless of whether try succeeds or the catch succeeds, finally will always be executed before jumping out of the method, right? So be careful about that. So let's close all of these and then go back to our to continue. So if you try to return a value from a method that is declared void, you will get a compiler error. And again, compiler and the JVM, they both expect basically types that are compatible. Now we haven't discussed polymorphism yet, but we saw classes and the object hierarchy. So I'm going to show you what I mean when I say compiler expects you to return. It doesn't expect you to return the exact type that the method declares. It expects you to return a type that is compatible. And we've already seen that compatibility means in the sense of inheritance. It means basically any subtype of a class is also of the type of the superclass. So any mountain bike in this example is a bike. So mountain bike is a type that is compatible with bicycle, right? And we can put this to the test. So let's see, return polymorphism. So let's also have a main method. Polymorphism just means that many shapes. So poly means many, and morph means shape, right? So polymorphism in the context of object-oriented programming means a similar shape or many shapes, which means that if a class can have many subclasses, which means now you're morphing that class into different shapes, different subclasses, right? But they all have some part of their identity is the superclass, the class that you originally intended with. So the subclasses are the many shapes of the superclass, right? So let's see. We're going to have a public static void test1, and then here we're just going to invoke test1, right? And actually I'm going to assign it to a variable a, and then maybe we eventually print it. So let's see. So this method right now it's void, but we're going to set this to bicycle, all right? And then do a sysout on the a, right? This bicycle that we're returning. So we're saying that we're declaring that this method is going to return a type that is bicycle. Now obviously static and public are not that important for this demonstration, but for now we're getting a compilation error because it says that, hey, you promised that this method is going to return something of this type. So you have to hold up your promise, right? That's the whole meaning of this compiler error. This method must return a result of type bicycle, And again, remember that when we said type, it means fully qualified name. And the reason that I'm not using the fully qualified name of the bicycle is because I'm in the same package. If I wasn't in a different package, either I have to use the import statement, which is the preferred way, or you use the fully qualified name. Just again, I repeat this many times throughout this course because it's the bread and butter of Java programming, is that it's the fully qualified name. It's what JVM understands, right? And as you can see, the compiler actually the compilation error doesn't change. And interesting that the compiler doesn't give you the fully it doesn't tell you the type is like dev_java.classes.bicycle. It just tells the name of the type. But you can use wherever you can use the name of the class, in fact you have to use the name of the type, which is the fully qualified name, right? But right now I'm going for simplicity remove this qualifier, these packages, because I'm in the same package, so I can directly use the name. I don't need an import statement, etc. So let's say we create a we can directly return a temporary. So approach one is to return a temporary. What this means is that we directly write the return statement, and if you recall from the lectures, was that anything that we can put any expression, any valid statement or expression after the return, and it gets executed first, and then the result of that execution is returned, right? So we can put anything, and obviously a valid statement is the invoking the new operator on the bicycle, for example, right? So bicycle, we have so this one. So we have a constructor for the bicycle that doesn't take any parameter and returns it. So this compiles fine. So and this is, we saw that this is a temporary, which means we don't immediately assign it to a reference type, to a local variable. So as soon as we come out of the scope of the method, right, when the method call returns, we lose access to this this temporary object. We created it, its state is initialized in the Java heap, but because we didn't save it in a local variable, we kind of lose access. But because the new operator actually returns a pointer or a reference to this object, and then we are returning that. Remember, when we say we return a bicycle, it means we are returning a reference. We are returning a pointer or reference to that object, right? So basically, when you see some class is the return type of a method, it means this method eventually is going to create some sort of object of this type and then return it, right? So, and what we return, we actually return a pointer or a reference to that object. So even though we get out of the scope of this method, because when we return back, this method is still returns this reference to that object and we assign it to a value, right? So therefore we don't really lose access to that. So we don't lose access to that bicycle object. So it's not garbage yet. It's not garbage yet, right? What this means is that as long as we have a pointer or a reference to that object that is created, regardless of where it was created in this method, we popped out of this method, the stack frame of this method is completely destroyed, all the local variables are destroyed, that's fine. We are still this method is still keeps a record of this reference that this new operator returns, and then it immediately returns it and we immediately assign it. I'm using var. If I hover over this variable a, it tells me that the type, the inferred type is bicycle. So no problem. I could also just directly assign it to a bicycle type, right? Now for local variables, obviously var has been a welcome addition to the programming syntax because you don't need to write the types, right? All right, and let's run this, and this code works fine. It just prints the default to-a-string implementation of the object class because bicycle inherits from object. Now approach 2 is to return a variable, a local variable. So we say that bicycle b b1 is new bicycle, all right, and then we return b1. Obviously I cannot have two return statements. We've seen this error before. The compiler is going to give us an error saying that this line is unreachable code. Unreachable code, because obviously as soon as you go inside the method you return, so this is not going to be invoked anyway. So I'm going to comment this out. Now it's very interesting what's happening, and there is a difference here between Java and C++. In C++, when you return a pointer, right, obviously when you return a local variable, you can, in C++, you can type something like this. So you create your object on the stack and then you return a pointer, right? You return that object, and that's very dangerous because when you jump out of the method, the stack frame is destroyed, that object is destroyed. Even you, so that the address or that object was only valid as a local variable, right? So you cannot do that. But but in C++, when you allocate on the heap, similar to Java, you get a pointer or a reference to it and you can return it. That's fine, because heap is somewhere that everybody can access it as long as they have a valid pointer to it, right? So this code is basically valid both in C++ and Java. And know that when we get out of the scope of this method, this b1 is destroyed. I want to be very clear about this. Be very clear that b1 will be destroyed. So b1 variable is no longer a seed, but the code is going to work fine. Why? Because when we return, basically what happens is that after the return, basically the value of this b1 is copied somewhere in the application, in the memory somewhere, and then that value is going to copy it back in this a, right? So we lose the b1 variable because it's a local variable. But then the value that b1 holds, we still get a copy of it. So therefore we still have a pointer or a reference to this object that this method creates. So this object is still not garbage, right? Now obviously this syntax is clearer, so I usually prefer to do this, but then creating a temporary and immediately returning is also something that people use. And we've seen that, for example, Eclipse has some code templates. So if you type var, it tells you that it creates this kind of codes, which is a nice feature. But with the introduction of var keyword for local variables, it's that feature of Eclipse is not really used anymore, right? Sometimes the type is very long, the name, so you just type var and the code is still going to work fine, which is nice. The compiler infers the type. But for now I'm going to so this code works fine. But we said that the return type doesn't have to be a bicycle. It can be any type that is compatible with bicycle, and polymorphism or object inheritance hierarchy allows that. So let's see, can we do create a mountain bike here? Did we have a constructor that, let's see what constructors are available for mountain bike. Start height, let's say 1, 0, 1, 2. Just random numbers. There is a constructor here, and then this is, and we are returning mountain bike, right? We created a mountain bike object, we didn't create a bicycle object. But surprisingly, the code still works fine. There is no compiler error. And if I run this, it still works fine, right? But you see some interesting things. First of all, this pointer b1, this variable type, was of type mountain bike, and we are returning it, but the return type is bicycle. And this works fine because every mountain bike is a bicycle, right? We could declare that this is a mountain bike to be more explicit, but then here nothing changes because any pointer, any variable of type mountain bike, basically it means this variable is pointing to a type object of type mountain bike, but that mountain bike is also a bicycle, so you can do that. So later when we look at the polymorphism in more details, you see that when we do this, assign, for example, this method returns a subclass, we assign it to a superclass, then we lose some of the functionalities of that variable, because now we don't have access to the methods that the mountain bike has, because this variable is supposed to point to the bicycle part of the mountain bike that we created, right? But this code still works fine. Yeah. But here's the difference between using the var keyword and explicitly writing the type. So obviously here the type of this variable a is explicitly written as bicycle, but if we write var and know that what type is inferred, mountain bike, so bicycle is not inferred, mountain bike, because var allows you to var tries to deduce the most explicit or type that it can infer, right? So the compiler looks at the return type, says, oh, you're returning a mountain bike, so this has to be a mountain bike, right? That's the most logical case. If you return a bicycle, obviously the compiler is going to confer bicycle. So var is very nice because sometimes you want to modify a method, right, from bicycle to mountain bike, and then you don't really need to change the code that uses var, because behind the scenes the compiler automatically at the compile time the bytecode changes, but the syntax of the source code doesn't change, right? So var is a nice feature here in terms of not changing the source code, but for example changing the return type of the method, right? So again, the point here was that the return type that the method expects has to be some type that is compatible. The keyword here is compatible return values or return types, which means if I say bicycle as the return type, then I can return any subtype or subclass of bicycle, because any subtype is actually a supertype, is also a supertype, right? Or any subtype, any mountain bike, part of the state of it is a bicycle. So I can convert a reference that points to a mountain bike to a reference that points to the bicycle part of the mountain bike. And in other programming languages like C++, it's called object slicing. I'm going to write it down. In Java, we don't usually use this terminology. Object slicing means whenever you say, for example, even here, when I create a mountain bike, I can assign it to a bicycle pointer. But then this B1 is only pointing to, is allowed to only point to that part of the mountain bike that is the state of its superclass bicycle, right? Again, all of these codes compile, but then the meanings are a little bit different. You don't have access with the B1, you don't access to the parts that of the mountain bike that is specific to the state of mountain bike, because B1 is supposed to only point to a bicycle object, or the slice, it basically slices the state of the mountain bike and then only keeps the superclass part. Now there are something called casting, which is a topic for future lectures, and that allows you to cast it back. I can say mountain bike B2 is basically I get the B1 and type a pair of round brackets and say mountain bike, right? What this does, this casts this back, because b1 is still pointing to this mountain bike object, but it only to the first slice, which is the super type. But we can cast it back to the compiler and saying that, hey, actually put the other part of the slice back into b1, and now it's pointing to b2, and we can return, for example, b2. This also works fine. And again, because var now the type is deduced as a bicycle, because that's the return type. But every mountain bike is a bicycle, so it's fine. So I hope you enjoyed this lecture and now have a good understanding of what the return type means, what it means when we say that the return, what you return has to be a type that is compatible. Now, in terms of primitive, we've seen implicit conversions are allowed, explicit conversions are not allowed. For example, if your method returns an int and you return a byte or short, that's fine. Implicit conversion is fine. But if your method returns a double and then you return, for example, if you your method returns an int, you return a double, you're going to get a compilation error, because implicit conversion of double to int is not allowed. The compiler doesn't allow it. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.